Misleading graphs. So a misleading graph is a statistical graph that is not drawn appropriately. This may occur when the creator of the graph wants to give viewers the impression that show results are better than they actually are. Below are some questions you can ask yourself when analyzing a statistical graph that will help you recognize when a graph is trying to deceive or mislead you. First of all, does the graph have a title? Do you know what it's actually talking about? Does the graph need a key? So for example, if there's two lines on the graph, have they been distinguished to tell you what they represent? Are the numbers of the scale evenly spaced? Are all the axes or sections of the graph labeled? Does the scale begin at 0? If not, is there a break in the graph that shows you that it doesn't start at 0? Are all the components of the graph, such as the bars, the same size? Analyzing misleading graphs. So example 4, describe how each graph is misleading. Then explain how someone might misinterpret what's going on in the graph. Let's start with example A. So example A, we're talking about tuition, room, and board at colleges and universities. On our y-axis, we have the average cost in dollars. And then on our x-axis, we have the academic school year. So it looks like to me between 2007 and 2008, a student would pay a little more than $16,500 to go to college versus in like 2008 to 2009, they would pay, it looks like, $17,200 or something in that, between $17,000 and $17,500 to go to college, etc. Now, why is this graph misleading? The first thing I'm recognizing is that this graph does not start at 0 and there's no break. Okay, so does not start at 0. Now, when I say there's no break, if you look over here, this is a break in the graph, which tells me, hey reader, be aware, this doesn't start at 0. This one doesn't have that. It starts at 15,500. Now, how would that lead me to misinterpret this? Okay, well, when I'm looking at this, given that I don't start at 0, do you notice that the distance between these two bars seems to me kind of, that's a big difference. So if I'm looking at this, I'm going, oh wow, the tuition from 2007 to 2008 and then 2008 to 2009 goes up a lot. And then it goes up a lot more, and then it goes up a lot more. So this college, wow, they're really charging a lot more money. But if you actually look at the number, this goes from like 16,600 to 17,200 or 300. That's not that big of a jump. So from 16,000, this is right here, this is $1,000. It's not even going up $1,000. So the difference in bar height seems drastic, meaning a lot. Where in reality, it's not even $1,000. Okay, so really the price from year to year is not even going up $1,000, even though $1,000 still seems like a lot of money, even though those bars seem really far spaced apart. Example B. Okay, what's going on in example B that might be misleading? So the first thing I'm noticing in example B is, do we notice down here, these are changing by 0.02. Then do you notice when we get up here that they're only changing by 0.1, or I'm sorry, 0.01. That's not right. That shouldn't happen. So if I'm looking at this, I'm probably looking from year 2011 to 2012, and this looks the largest. So it looks like from 2011 to 2012, we got the largest wage increase. But keep in mind, this is only going up by 0.1 or 0.01. Whereas here, this doesn't look as large as that, but each increment here is going up by 0.02, which is actually more. This is the largest increase. So actually, if I'm looking at this graph, the largest increase in wages happened from 2009 to 2010, even though it looks like the largest increase was from 2011 to 2012. That's very misleading.